Hi there, Mr. Sutton here, bringing you the IM3 Honors 4-7 Part 2 homework solutions on systems of inequalities. To graph this system of inequalities, we're going to graph each inequality individually and see where they overlap. So our first inequality is a line in y equals mx plus b form. We have a y-intercept of 4, so we'll put a dot on 4. Now, because the inequality has no equals, we're going to use an open dot. So that's 0, 4, open dot right there. And then we have a slope of negative 1/2 that we'll use to get the next point. So starting at 0, 4, we go down 1, right 2, and put another open dot. Since we have open dots, we're going to use a dashed line to go through those. And because our inequality is less than, y less than, we're going to shade below the line that we just drew. So everything underneath. All right, let's move on to the next one here. This is a parabola. To graph this, since this is in standard form, we're going to start by getting the vertex and then the y-intercept after that. So our vertex, we've got negative b over 2a in general. So that's going to be negative 4 over 2 times negative 1. That's 4 over negative 2, which is negative 2. That's the x value of our vertex. To get the y value, we'll plug that back in for x. So we've got negative 2 squared minus 4 times negative 2 plus 3. And let's see here. This is going to be 4 if I square that, but then that becomes negative. So we have a negative 4. Over here we have an 8. Negative 4 plus 8 is going to be 4. And then 4 plus this last 3 gives us 7. So that is the point negative 2, 7 that we've got for our vertex. Now, since this inequality also did not have an equals, we're going to use an open dot on negative 2, 7. So back 2, up, let's see, there's 5, 6, 7 right there. For our next point, we'll get the y-intercept, which is this constant here of 3. So that's going to be right about here. Another open dot. And then we'll draw a half of a parabola going from our vertex through this y-intercept, and then we'll use symmetry to go the other way. So we've got another dot on this other side, same distance away. We'll draw a line through that, a parabola half through that, and since we are less than, y less than here, we're shading below this parabola as well. So everything underneath the parabola, including this white stuff here. So there we go. Now for the actual solution, we need to shade a little bit darker where we're overlapping. That's going to be in this purple region in here where they share the shading. So we'll shade a little bit darker in there, and that's our solution. For this one, I'm trying to graph the solution set for this system of inequalities. To do so, I will graph each inequality by itself and then see where things overlap. So for the first one, we've got a line in y equals mx plus b form. I have a y-intercept of negative 1. So I'll put a dot on 0, negative 1 here. Now, what kind of dot am I going to use? Well, since I have the equals under my inequality, that's going to be a solid dot that I'm putting down here. And now I can use my slope of negative 1/3 to draw another dot. So starting at my y-intercept, I'm going to go down 1, right 3. There's my next dot. And a solid line going through those. The less than for my inequality tells me I'm shading below with the line I just drew, so everything underneath here. And I move on to the next one, y less than negative 2. So this is a horizontal line going through negative 2. Since we don't have any x here, we know it's a horizontal line. So down here, we have a horizontal line, and since I have no equals, this is going to be a dashed line going through negative 2, the y value, negative 2. Also shading below because we have less than for the inequality. So let me shade everything underneath there. And then the only thing I'm going to shade for my solution set is where they're overlapping. So that's actually most of the stuff that was already under y less than negative 2, except for this little sliver right here. So everything else I'm going to shade a little bit darker, and that's my solution set. To graph the solution set for this system of inequalities, I will graph each one by itself and then see where things overlap. So for the first one, this is y equals negative 6. This is a horizontal line using Hoivux here. Horizontal line, if we just have a y, going through negative 6, so down here. Now, because there's no equals on this inequality, this is going to be a dashed line through y equals -6, like so. And the greater than here, y greater than, is telling me I have to shade above the line I just drew. So that's everything up here. Next, we have x greater than 3. We don't have a y here, so this is just a vertical line going through x equals 3. And because I do not have the equals, this is going to be a dashed line, so dashed line through x equals 3. And then greater than with an x value means that we're going to shade to the right. I mean, we can't go above a vertical line, so we're shading to the right. So that's everything over to the right of that vertical line. And if we look at where we're overlapping, it's going to be this little rectangular region in here, except for this little blue spot down here. Everything else here is being shaded a little bit darker for our solution set. For this one, I'm going to graph each of these inequalities by themselves and then see where things overlap to get the solution set. My first inequality is a parabola, a quadratic, in standard form. So I'm going to use -b over 2a to find the vertex, and then I'll use the y-intercept in a little symmetry to get the other points. So -b over 2a gets us the x value of the vertex. That's -4 over 2 times -2. That's 4 over -4, which comes out to -1. And if I plug -1 back into the original quadratic here, so swap out all those x's for -1s, that'll give me the y value of the vertex. So -2 or -1 squared is 1 times -2 gives us -2 for that whole first term. So we've got -2 plus 4, which gives us a total of +2 so far. And then 2 plus a 1 gives us 3 for the grand total there. So that's -1, 3 for the vertex. So that is right over here. Now this is going to be a solid dot because we have the equals under the inequality, so solid dot at -1, 3. We have a y-intercept according to this little constant here, this +1. That's a y-intercept of 1. So that's going to be, let's see here, right here. So we've got one branch going through there. And using a little symmetry, we've got another dot right on the other side. So I'll draw another branch through that spot right there. Now the inequality is less than, so that means I'm shading below the parabola I just drew. So that's everything under here. Next, I've got the vertical line x greater than -1. There's no y, so that has to be a vertical line. That's going to be a vertical line going through -1 here. No equals under the inequality means it is a dashed line through -1. And greater than means we shade to the right of that. So that's everything to the right of that vertical line. And we see here that we have an overlapping region, this little half parabola space here that will shade a little bit darker for the solution set. For this problem, I have to graph a system of inequalities solution for not one but 2 quadratic inequalities. So it's kind of final boss battle time here. So for both of these, since they're in standard form, I'm going to use -b over 2a to find the vertices of each one. And then I'll get the y-intercept and symmetry to get the other points. So we've got -b over 2a giving us the x value of the vertex on this first parabola. That's going to be -8 over 2 times the a value 4. So that's +8 over 8, which is 1. Plugging that in to get the y value from those x values, we've got 4 minus 8, which is -4, and then -4 plus 7 gives me 3. So 1, 3 is that vertex. Since I have the equals under my inequality, that means I have a solid dot and solid lines that we're going to use for this one. So 1, 3 right there. This plus 7 is telling me I have a y-intercept of 7 for that parabola. So that's up here, another solid dot. And let me draw a branch going through those. And I'll use symmetry now, flipping over that vertex axis of symmetry to get another dot here that I'll draw the other branch through. Since I have greater than for the inequality, that means I'm shading above. Y greater than, shade above. So that's all the stuff up here. Now I move on to the next one. -b over 2a again gives me the vertex, so that's -4 over 2 times 2 this time around. -4 over 4 gives me -1 for the x value of the vertex. And now plugging that back into this parabola, this quadratic, to get a y value, 2 times negative 1 squared is really just 2 times 1, or just 2. So we've got 2 minus 4 gives me negative 2, and negative 2 plus 6 gives me 4. So negative 1 comma 4. Since we have no equals for this inequality, we have an open dot on negative 1 comma 4 for the vertex, so that's right here. 6, this plus 6 is saying I have a y-intercept of 6 for this one. So another open dot at 6 right here. And I've got a dashed line going through that branch. And using symmetry, I'll have another open dot over here that I can draw a dashed line through as well. This inequality is less than. Why less than means we are shading below. Now, below this dashed parabola kind of looks like we're shading outside of it, but it's really everything underneath, and also all this stuff is underneath, so is all this stuff over here. Because if we went high enough up, our parabola would extend this far left and this far to the right. So it's all this stuff down here that gets shaded for that stuff. Now we see we have some overlap right here that we can shade a little bit darker, and that's going to be our solution set. For number 4, we have to graph this solution set with the parabola and a line, horizontal line. Let's do the parabola first. And on this parabola, we're going to have open dots and dashed lines because there's no equals. So let's find our vertex. Negative b over 2a will help us find that. That'll be the x value of our vertex. Negative 2 over 2 times negative 1. That comes out to just positive 1. Plugging that back in here, we've got negative 1 plus 2, which is positive 1, plus another 2, which is a 3. So 1 comma 3 is our vertex. Open dots right there. And then we have a y-intercept at 2. So let's put that on here as well. And we'll use symmetry to get another matching point on the other side of the vertex and a dashed line to go with it. All right, so now we have greater than. We're going to shade above that parabola in this area here. This next one is just a horizontal line through 1. Solid line because we have the equals. So here's our horizontal line. It's less than, so we're shading lower than the line. So that's going to be this area, this whole area under here. But now the solution set where they overlap, we're going to have one spot over here and another spot over here.